So when you finish, just end the meeting and the recording will come through to me. As I was saying, I'm leaving for Goa early morning, so I will put a copy a bit later. That's all.
Yeah, before you go, it says that the host disabled participants screen sharing. So you need to
say it again.
Enable. So
yeah, I'm
saying
making
that
the host. No, I'm making you the host. Just 1 minute.
Okay.
Okay, so you're now host.
Okay, now let me see if I'm host, should be able to share my screen.
So you can make anybody else a co-host if you wish.
Yeah, who else should be the host?
No, just you and Gopal. Currently, that's all the instructions I have from SAP.
Okay, so I will make Gopal the host.
No, co-host.
First of all, let me
make him co-host or host. One of you can be the host. That's it.
Okay, let me see if I can do that right now.
Now, isn't he already a co-host?
Gopal, are you there?
Yeah,
I'm here.
Co-host. And he's co-host already, so no problems.
No, he's not. Oh, yeah, he is co-host. Okay, so we're good.
Yeah.
So, you guys tell me if you can see my screen, because that's going to be kind of important.
Yeah, we can see your screen.
Okay, so let me see if I can convert to slideshow mode. Okay.
Yep. You're all set.
All right. Good to go.
Okay.
I can't see you.
Okay, Sinet, we'll wait for another 4 or 5 minutes.
Okay. I'm going to set up so I can see who's on the call. Okay, here. All right. I think we're good to go. Fancy Ken Singh.
Hello.
How are you doing?
Hello. Fine, fine. How are you doing?
Very good. I am trying to get this thing organized here. Okay. All right. I'm going to just step out for just a second while I get some water. Get right back. Okay, guys, I'm back. Who have you added here? Sanjeev Rangras.
Shirish Netke.
And there you are. So which continent are you in right now?
I am very much in India, buddy. It's just that Saturday evening is always a challenge. Today, of all times, I was in Calcutta and I found that I had time. So I said I must log in.
Very good. Nice to have you. Shraddha Saab.
Thank you so much.
I can see you.
Chadda Saab, Bridge Mohal.
Raj,
Yeah, guys.
Brijraj is a serial wedding attender. सब weddings में दिखता है साला कहीं का. Serial, मतलब वो होता है ना serial killer. You are a serial wedding attender.
No, Rangi, he's a serial. He's the only person who gets invited for everybody. That is the point.
Yes, you are right. I never thought of that. I'm feeling suddenly left out.
Nothing.
the key is in getting invited and showing up. Hey, Murali.
He's showing up. Yeah, he shows up. Yeah.
Yeah,
Hello.
showing
How
up
are you,
is
buddy?
also-
How are you, Dr.
Looks like you're
Netke? How are you?
Very good.
Ready? Yeah, I'm all ready with some yoga blocks to listen to your blockchain.
Yoga block.
I just
Okay, good.
I just got back from yoga. I said I had a yoga class in my gym, so I just
Okay.
got back. So I'm ready. I'm ready and refreshed for your. I know the last.
Very nice.
Just to let you know, in 20 years back, when e-commerce was inception, I read some book, and Shirish Netke's book name was quoted in that. When I was doing my MBA, I think there was some. Your name was there actually, Shirish. I think that time you were in Sun or something. So from
Many years ago.
e-commerce, you moved to blockchain. Yeah, that's excellent. You're reinventing yourself every time. Great.
Yeah, it is block and not black, Murli.
That is a Freudian slip. Murali, what have you
Okay.
been doing on the blockchain?
Black.
Sounds good, buddy. Sounds good.
On the blockchain.
Okay, guys, I think we have enough people, so we can start. So,
Yeah.
couple of usual notes. Please don't ask questions directly. Post it on the chat, and every so often we'll stop, and Shirish will answer the questions. And number two, please mute yourself if you're not talking, which you should not be most of the time. So please mute yourself. I'll start out by introducing Shirish. I think almost everyone knows Shirish, or as he's known recently as the Don of the Bay Area. And over the many years, he's been involved in business processes and technologies and e-commerce. He started his work off at Sun, and he's got many stories about Scott McNealy and others, which are really fun to hear. So we should listen to that sometime. We should have a bull session on that. For the past about, correct me, Shirish, for past about 7 or 8 years, he started his own fintech company called Amberoon, where they provide risk management solutions for banks, especially in this day of a lot of fraud and cheating going on. So they use AI and machine learning and blockchain to find problems and suspicious transactions in banks. So one thing unique about Shirish that I don't think most of us have done is he's testified as an industry expert before both the California state legislature and the US Congress, which I think is a very unique attribute, which I don't think anyone else has done. So without much further ado, Shirish, it's yours.
All right. Thank you, Gopal. So, like my father used to say that if you talk about your own achievements, you're an idiot. But he did make an exception, saying somebody else talks about it, it's okay. That's you get a pass. So, with that, thank you, Gopal, for that introduction. Let's go in and go straight in. We're going to talk about blockchain as opposed to Bitcoin or let's say more commonly used words in the crypto lexicon right now. The title of the talk is Mad and Bad, but not a fad. You guys can look up what Mad and Bad means. It refers to it's a 16th century reference to a guy called Lord Byron, which his girlfriend called him Mad and Bad. I'll let you guys Google that. The important thing is we want to cover sort of the good, the bad, the ugly about blockchain. And I've divided this discussion into 3 parts. I would say probably 4 parts is more like it. A little bit of a historical context of what this means, some background on the foundation technologies, what are the technologies that it's based on, Then we'll talk a little bit about the application of those technologies in the context on financial services. And I know a lot of you guys are not in the financial services area, but that's an area I understand. I am going to talk a lot about a area of application which is kind of close to all of us, which all of you will identify with, and you guys, let's have to wait to see what it is. And then we talk a little bit about regulation, because regulation has also been studied pretty extensively in this area. So, so if you look at it here, I mean, look at the audience here. A lot of us think that we don't know enough about the blockchain or about the associated technology behind it. And I would probably, at the end of this talk, I'd probably want to convince all you guys you actually already know about it, because it's not a new technology. And we've studied it in some form or the other. And yes, we have a lot of people explaining what this technology does. And some explanations are better than others. So we have like the comics, the wags, the people who don't know what they're talking about, some people who do know what they're talking about, explaining what this is all about. But to put everything into context for us, we should probably look at defining a few, I guess, times in history. So I've chosen kind of 3 times in history. And these are the publication of various items here. How many of, I guess this is not an interactive mode, but some of you may have heard of Satoshi Nakamoto, the author of the Bitcoin white paper. Stuart Haber and Scott, a lesser number of people would have heard of. He's the guy who wrote a paper on how to timestamp a digital document. It's a big deal when it was written. And then there's a guy called Friar Luca, also known as the Drunken Monk, from a few centuries ago. And we're going to talk a little bit about all of these guys, because they, in one way or the other, had to do with the blockchain. So let's go to Satoshi Nakamoto. You can get into the details of the white paper that he wrote on Bitcoin in 2008, 2009. But in very simple terms, it's he introduced a system called Bitcoin, which allows online payments to go from peer to peer, from one person to the other without the financial institution. That was the crux of it. This was in the, I guess, the wake of the financial crisis, where a lot of, let's say, what we call cypherpunks and people in the industry, people who are more of a libertarian mindset got in and came up with a solution. And he introduced the concept of a decentralized network, which was using cryptography and a lot of pretty novel concepts, blockchain being one of them, to talk about how financial.
So iPhone, can you mute yourself? 1 minute, Shirish. iPhone, can you mute yourself?
Gopal, you can mute them as well.
I'll send you the recording.
Okay, I'll see if I can mute. Okay, yeah. So that was Satoshi Nakamoto, who I think most of you have heard of. Reality, of course, is nobody knows who he is. With one person or many people, he is still pseudonymous. Now let's go to the. Okay, now let's go to this guy, Stuart Haber and W. Scott. These are guys from, I guess, from Bell Labs, who talked about, probably this guy, Sanjay Patel would know. They're probably from that general neighborhood, who talked about securely timestamping digital documents. It's a pretty big deal, because this was in 1991, and they talked about the whole idea of putting a time. It sounds like a pretty novel concept, but it was a big deal at that time. In a sense, it is also a big deal right now, because this concept didn't quite exist in the form that until these guys talked about it. So in a sense, a lot of these guys, both of these are considered as the first or the fathers of the concept of a blockchain. Then we had the Drunken Monk, Friar Luca Pacioli. How many of you guys have heard of him? I guess you can't raise hands here, but some of you have not. Some of us have been to MBA school. He is the guy who there you are. Sanjeev Ragras has heard of him. Oh, you haven't? Okay. He's the guy who invented the double entry system of accounting. In his seminal work, which is in Italian, so I couldn't quite read what he says. He was a contemporary of Leonardo da Vinci, so he's a Renaissance man. In fact, he's supposed to have been the tutor of his math tutor for Leonardo da Vinci. And he came up with the concept of debits and credits, which basically means that you can, whenever you have, when you're taking an account of something, you put it in two places, so it becomes easier to check on stuff. And I think he did it to keep track of wine bottles in the winery, in the priesthood or somewhere, something like that. But the story is that he's the guy who documented the area of the concept of double entry accounting. And that sort of leads me to the basic assertion that blockchain, all of you guys think about blockchain is about computer, it's about network, it's about technology. Blockchain is really about a ledger. And without the ledger, we really can't be talking about, okay, I think I've jumped a couple of slides here. How do I go back? Okay. All right. I figured it out, how to make this work. Okay. So Fra Luca Pacioli is the first blockchain bro, the blockchain numero uno, blockchain bro numero uno, so to speak. Basically, what he said was every entry to an account requires a corresponding and opposite entry to a different account. And all entries are maintained in a ledger, and the ledger is the single source of the truth. The ledger is secure, the ledger is immutable. And the blockchain is essentially a distributed ledger. You can't mess with it. Once it's written down, it's there. And once you sort of get to this understanding of this concept, all the other kind of supporting technologies that evolved over the last few hundred years kind of came about as a result of this concept. Now, incidentally, Luca Pacioli said he didn't invent it. Somebody else did, and he wrote it down. But he was truly what is called a Renaissance man. There's a picture of him with one of Leonardo's works in the back, and him writing stuff in a ledger. That's what the picture is supposed to depict. So, okay, so what's the blockchain today? The blockchain today is a secure, decentralized ledger maintained by a network of computers. This is the modern technology. And this ledger is immutable, meaning that once data is added, it can't be altered. It is secure, it's transparent, and permanent to all permanent and is a permanent record of all transactions. Now, this is probably what you'll recognize in I guess as the foundational technologies that are being used right now. They are networking, cryptography, and a consensus mechanism. Let's talk about these in a little bit more detail because it sort of will give you an idea that you may know a lot more about blockchain than you may think because you already are using these in some form or the other. So let's look at networking. So some of you guys may recognize this as the networking layer diagram, the internet protocol stack, or whatever variation of you would call it. But basically, this is the networking stack. And all of us, at least some of us, already know that there are multiple layers of the network stack, beginning with the physical layer. We have the Ethernet after that, the internet protocol, the transportation communication protocol, and then the application. So this is kind of the established form of networking or communicating, or the other protocols which have already been defined. Blockchain has inserted itself somewhere in between there, between the top two layers, and that's how it fits in with the rest of the protocol. Now, this was a non-trivial achievement. I mean, those of you know about the history of computing, the fact that one computer could talk to the other was a big fucking deal. Sorry, is this being recorded? Oh, probably. Well, okay, you can edit that out. The fact that they could be recorded and they could communicate with each other was a big deal. This led to the concept of, or rather the quip by my former boss who said the network is the computer. The network, without the network, there is no computer. Without the computer, without networking, there is no productivity in computing. So this is what this is about. And the blockchain kind of inserted itself right in there, right afterwards. The other key concept is cryptography. Cryptography, again, all of us have some kind of understanding of whether, depending on the level of detail you want to go into, but essentially we are talking, when you talk about cryptography, you talk about the ability to encrypt and decrypt data. There is actually a Sun connection. There's a Sun story in here, which is Whitfield Diffie, one of the guys who wrote about public key encryption, had an office next to me, and I didn't know who he was until he showed up on the front page of the newspaper the day, and then he recognized the name and the face and everything. But the point is that this was a revolutionary concept in the 70s. There was something called RSA encryption, which came up, which made it possible to share data over a public exchange without compromising its integrity or compromising its privacy. And essentially, and you can study this separately. It has to do with the multiplication and factorization of prime numbers, and probably someone like Kapil Parajpe could probably talk about that at length. But as far as our purposes concerned, this is one of the foundation technologies of keeping data secure and private, and it's one of the building blocks of what we call the blockchain right now. The third thing, this is something which may be more of which you would have heard of, but it's just kind of more of a novel, I would say novel, it's a more recent concept that's being studied, which means that is consensus. This consensus means whenever you commit to a item in the registry, that means if you're trying to make an entry in the ledger, like Luca Pacioli did about 400 years ago, it has to be with the consensus of all the other people who are maintaining the ledger, so that it can be tamper-proof. And this is how should I put it, a very time-consuming process, or a resource-intensive process. So all that stuff we hear about in terms of electricity being consumed by Bitcoin, and basically the cost of a Bitcoin costing more, cutting down 1 million trees and that kind of stuff, that is because of the consensus protocols that are used. And I won't get into the technology, but I just want to get into the reasons of why this is important. And the reason it becomes important is that the more time you spend on building consensus, the more inefficient it is, because you waste trees, you waste electricity, and everything else that goes with it. But you have to do it because you have to form a consensus about what is in the what was considered as the final entry into the ledger. Again, think of the blockchain in terms of a ledger, and everything else becomes kind of simplified. You don't have to know about the underlying technology behind it for purposes of understanding this part of it. Now, the other aspect, which a nuance you want to mention about the consensus, is that consensus means that if you have, let's say, thousands or hundreds of thousands of nodes on the network, all of them agreeing to something, you can argue that if let's say more than 51% of the people make the change, they can overwrite history, overwrite the truth, overwrite a lot of what other people have done, and mess with the system, basically. And that is absolutely true, except that the way the network is laid out, and this is kind of one of the things I would probably say is Satoshi Nakamoto's contribution, is that if there are literally hundreds of thousands of places where you have to update it, the cost of making a change that is for 51% of the people is so high that it is not practical. So the consensus thing is, as a concept, needs to be understood, I guess, when you talk about blockchain. But what it does at the end of the day is it brings confidence to people who are relying on the data in there to ensure that they are that it is reliable and it is true. Now, the one thing I would add on to this is going back to the whole story of what is called the resources that are consumed in getting consensus. There are essentially three different ways. I guess there were first of all, when we started off in 2008 till about 2015, there was only proof of work, and proof of work was computational power. That's how Bitcoins were mined and are still mined right now. That means you have to spend a huge amount, I guess probably not at that time, but now you have to spend a huge amount of money or computational resources to get to what is called a proof of work, which is part of demonstrating consensus. So this is considered as very low on energy efficiency. It requires hardware, advanced hardware. We talked about NVIDIA chips, and Gopal talked pretty extensively about hardware in the past. This is where a lot of things got consumed, and in fact, NVIDIA made its fortunes about the time when there was a burst, when Bitcoin came to life, and we needed a lot of GPUs to do with it. Security is high, and you're essentially, in simple terms, what you're doing is solving puzzles, and that's what Bitcoin was all about. Around 2014 or 2015, the Ethereum came along, which did what is called economic stake. There is something which are kind of more simply known as gas fees. That means the more you pay, the more you can actually get access to do more computation and do what is called a proof of stake for completing the consensus. Security is medium high. There are a lot of coins that are using it right now. But the most modern thing, which some of us, which in fact a lot of people in this blockchain community have not even heard of or not actively talking about, is what is called proof of space. Proof of space is the use of disk storage space. And this is kind of my favorite right now because the amount of resources consumed is about 1/600th or 1,000th that of, let's say, Bitcoin. And this kind of changes the entire dynamics, the entire economics behind it, and also the arguments behind carbon footprint are all sort of turned over when you talk about proof of space. Now, proof of space is essentially sharing disk storage space. That means instead of buying CPUs and GPUs, you buy disk drives, and more of them disk drives, probably some memory as well. And as we know, the cost of disk space and even memory space is going down pretty drastically from year on year, which makes this much more energy efficient. It makes it much more, let's say, user environmentally friendly to implement. One thing is significant is that when the World Bank or the IFC came out with a carbon credit exchange, they've used what is called proof of space. So you can't be trading carbon credits and be using an inefficient system like Ethereum. So they use the proof of space. That was kind of the endorsement behind the use of that idea. And we can go into more of that later. But the idea is that the big deal why I'm even mentioning it is because consensus is a big deal. Consensus is bloody expensive. And it's a kind of it hurts the entire, it hurts the environment. It has a lot of downsides to it. And by technologies like proof of space are being adopted right now to basically address that problem. So it kind of boils down to what does a blockchain look like? Now, this is a depiction of what Bitcoin looks like. Now, what you have here, this again.
Shirish, before you go into the next one, I think there are a couple of questions which are relevant here. Okay, so Sanjay, do you want to, Sanjay Patel, why don't you?
Okay, just I was trying to understand consensus and ledger entry, the synchronicity. So my question was, consensus has to be synchronous with ledger entry, or can entry be revoked later? And I'm guessing it has to be synchronous to prevent unrolling later entries or the impact crater of something being removed, you know. So how, I mean, that could slow down, if consensus is bloody expensive, it could slow down the dynamic ledger entries. So how can you put some color around that so I can understand it better?
Yeah. So first of all, a ledger entry once done can't be changed. So it's a done deal. So yes, it can slow things down, and that's the reason why you have, I guess, the GPUs and the high-powered systems to be able to make it faster and better. So a lot of those folks who you see are mining of Bitcoin, they use high-powered stuff, because if they don't put that much power behind it, the thing does not work. So I would say that it can be slowed down, and the counter to that, if you want to, the counter to that is to basically to make it faster is to throw more processing power at it. Once a ledger entry is done, you can change it, of course, but then it has to be changed across the board everywhere so that everybody catches up with it. Typically, what some of the exchanges also do is that they might say that they won't wait for the entire consensus to happen. You can actually say that if they've got a good enough consensus is like I would say straw poll or exit poll at an election. You have a good enough idea that the thing is committed. You put it in there, and then if it has to be rolled back, then there is a mechanism. But there is some kind of mechanism rolling it back. But you're right in the sense that it is expensive and it takes a lot of time to do, and it is very resource intensive for everybody concerned.
No, but Shirish, in software development, again, there are better Maharathis of doing that. But my recollection is we used to do local integrations teams. So are there local, blockchain ledgers that are then integrated or into the mainstream, as we would call in our software developments, or are there is a master ledger in which everybody basically makes and reaches consensus and makes entries too?
No, that's actually a good question. There is no master in here. Everybody is. This is a peer-to-peer network. That means it has to be updated across the board. But the fact that you update it locally, you may have something called as a permission blockchain, which is just a bunch of people around it, which is much easier to maintain. But when it's across the board, there is no master, there is no slave. The whole, let's say, the validity or the credibility of the ledger is that it's updated across the board at every location. So anybody can, at any point of time, look up any transaction on Bitcoin. It's a lot of them, but yes, it has to be updated.
Okay.
So,
Shirish, one more question from BS, which actually is...
I can answer. Yeah, go ahead. Go ahead.
Right. Why is Bitcoin mining so energy intensive?
Well, it's because of this. It's because of the computational power that's required. You have to, the process of establishing consensus is a resource intensive process. But imagine you have to go through the entire network, make sure that the data is updated in all those places. That's what takes a lot of time. And the way, and it is only energy, let's say, expensive if you are using the proof of work model. That means you have to show that you solved a certain puzzle, which requires a lot of computational power to solve, and that basically is the expensive part of it. If you use a what is called a proof of space model, that means you validate it based on storage of on data, it becomes much cheaper. So yeah, it is. This is expensive depending on how you do it.
There's one more question.
Yeah.
There's one more question, and I think I'll tell you two questions, one from Rangras and one from Subodh. Subodh says, I can't get a link between consensus and POW, POS, PO space. And Sanjeev wants to know what's the meaning of mining a Bitcoin.
Okay. So let me answer Subodh's question first. POW, POS, PO space are means of getting consensus, are different ways in which consensus is obtained. And as I said, one of them is more efficient than the other. One is more energy efficient than the other. As far as mining is essentially the creation of Bitcoin. So there is a certain amount of Bitcoins available. The mining of Bitcoin basically means creating of a block on the blockchain, the picture which you saw over here. And this, because for creating a block, as a miner, you get paid in terms of Bitcoin, a part of Bitcoin. So the mining is essentially a way of creating Bitcoin or doing work for the consensus protocol to support the consensus process. And for your efforts, you are rewarded with the coin, and that's why it's called mining. So the analogy is like gold mining. You do a lot of work, and then you finally find some gold, and that becomes yours. In this sense, if you do a lot of work in supporting the way consensus happens, you get rewarded for it. And I mean, just as a bit of a side note, the number of coins that are available totally is about some 23 million. They go down significantly from year to year. So the cost of mining just goes up very much. Right from the time in 2009 when it was started to now, the cost of mining that same Bitcoin is much higher.
Shirish, why do the number of bitcoins reduce?
That's the way Bitcoin is defined. Bitcoin is they don't reduce. There is only a finite number of bitcoins that can be mined, and I think the number was set to 23 million. And every so often, I think every 3 or 4 years, the numbers that is available to be mined goes down. So they don't reduce. The total number of possible bitcoins available in the system is only 20 plus million, but the amount that are available to be mined just go down every year, and they kind of I think they go down over a longer period of time. So the number of bitcoins don't reduce. The total number that are available remain the same, and that in a sense is what causes the value of it. If you've got that much of Bitcoin, that there are other economic factors, but the value of each Bitcoin keeps going higher. Does that answer your question, Subodh?
Subodh, do you still have your question? I see your hand is raised.
Yeah, Shirish, can you give an example of how one of them, POW, makes a consensus? How does it work?
The way it works is there is a what do you call a puzzle that is solved, if you will, which is a computationally intensive puzzle. That's where a lot of the I guess the CPU or compute intensity goes in. Once you are able to prove that you're able to you're able to solve that puzzle, you are that basically allows you to create another block, and the creation of that block gives you an allocation to a Bitcoin, which is as part of the mining. So I can get into a little bit more detail separately, but the point is that it is a compute intensive effort when we do proof of work, and at the end of the day, you're proving that you had taken the computational effort to solve that puzzle, and therefore you deserve to be a part of that system. So let's keep that. I can talk to you about that separately, Subodh, because but one thing which is important to note here is that all of these are forms of building consensus. Some are more cheaper than others, some are more expensive, and there's a lot of work going on to figure out how to make this more efficient and more effective and faster.
I think those are the only questions, Shirish. I think we can move on.
Okay, so let's move on to let's say some of the commercial aspects of it. Once you realize that the blockchain is about a ledger, the primary function of the blockchain is validation, because it's very hard to change. It's very hard to move things around on it. So we say that that's kind of the biggest value add that blockchain brings to the table is validation. Now, I want to introduce, but before I go ahead, we talked about the 3 technologies before. We talked about cryptography, we talked about networking, and we talked about consensus. Those are what we would call the foundation technologies. I want to focus on a little bit more on a few new concepts which are pertinent to the application of blockchain in a commercial context. Again, given that the primary value of the blockchain, as we see it, as I see it, is validation. So one of them is the concept of what you call verifiable credentials. Once you sort of think about it, it's kind of intuitively obvious. A simple form of verifiable credential, or the example used is you go to a bar or you go to a nightclub. There's a bouncer at the outside. He wants to see your verifiable credential. He wants to see your driver's license. Now, the important piece of data that he is looking for is whether you're above 18 or below 18, because that's the law. You can't be allowed to drive. You can't be allowed to enter the nightclub. You can't buy liquor or whatever until you're 19 years old or above. Now, this is kind of important because in the process of doing that, the bouncer also knows your age, your exact age above 19, your birthday, your address, the color of your hair, and whether you're an organ donor or not. That is gratuitous information for the purposes of what the bouncer should be knowing. And for that purpose, there is the concept of what we call verifiable credentials, where we are able to create, using the blockchain, we're able to create a validation of a person's credential without sharing what it is, without getting into too much of gratuitous information. Now, this validation is tamper-proof, and it is digital verification of a certain quantity. So, for example, if you are using a digital ID or a digital version of a credential, all it would say is yes, you're above the age of 18, or no, you're not above the age of 18. That's enough for you to get through the bar. This has been a concept which has been talked about for a very long time, at least for the last 25 years. But 25 years ago, we got this concept of what is called opaque handles, and the use case there was between Stanford and Berkeley. If you're a student at Stanford and you want to borrow a book at Berkeley, they have an exchange program where one student can go to the other. Now, in the process of doing so, the librarian at Berkeley would ask for all kinds of information for proof that a person was a student of Stanford, which was way beyond what was really required. And this was an initiative called Shibboleth at that time, run by a lot of the universities in the 1990s, where they created the concept of what is called an opaque handle. The opaque handle basically gives you the minimal amount of information to prove that you are who you say you are, or to prove a certain credential, and that's enough for you to, let's say, if you're a Stanford student, to borrow a book from the Berkeley Library, and vice versa. You don't need to know whether you're a graduate student or undergraduate student, what your GPA is, what your medical history is. All of that is gratuitous information, which is not needed. And that's one of the places where blockchain is being used right now, where there is an issuer of a VC or of a verifiable credential. There is someone who holds a verifiable credential, and then there is a verifiable data registry, which is maintained over here. This is kind of pertinent to the application that we're talking about. And I want to pause here because I'm sure there are some questions here which I have to get past before we get into the next stage of it. So, guys, do you have any questions on what a verifiable credential is and how it relates to the blockchain? No? Okay. Well, I'll just assume it's understood, and we'll discuss it again at a later point where it's being applied. The other concept is what is called self-sovereign identity. It's a variation of the same concept in the sense that any data that you have about yourself is owned by you and not by a central repository or person. Let's take an example of credit card data. So if you're in the US, your credit card data is maintained by people like Experian or TransUnion or some of the other guys. That is technically your data, and they have maintained it in a central location, which can get compromised, and it has a lot of risks associated with it. But it's technically your data, and they do need your permission before sharing with anybody else. And sometimes it works, sometimes it doesn't. In the case of self-sovereign identity, the concept of self-sovereign identity means that you have complete control over your data. That means you are storing it, for example, in a secure wallet. You're able to produce that wallet whenever you need to, and you're able to share only that data that is relevant to the transaction. So in the case of the bouncer in the bar, only thing you need to share is that you're above 18. Or if you're a student from Stanford going to Berkeley, only thing you have to show is that you are a student in good standing. You don't need to share a lot more information. Now, this is is fundamental to a lot of applications if you can imagine, in banking and financial services. I'll give you an example of this. We do the way, let's say, KYC works in banks, and we can talk about it a little bit more detail later. But basically, know your customer data in a bank is something you have to share when you talk to the bank, and you go from one bank to the other. They ask those questions all over again, and they have to share it by law, by regulation. And you're doing the same work over and over and over again. If that is moved to what is called a self-sovereign identity using a verifiable credential, it's done only once. The data is maintained by the owner of data, and it's put in what you would call an immutable, impenetrable ledger or a wallet, which nobody else can see and nobody else has control over except the owner of that data. So both of these are kind of important concepts, which I wanted to sort of get across before we get into some of the use cases that we're talking about. And this is what I wanted to do here is instead of talking about some of the more exotic use cases, I wanted to talk about a use case that is being discussed right now with our dearly beloved alma mater.
Shirish, I have a question. So you keep talking about wallets. Where are these wallets stored?
Yeah, they can be stored either in an exchange or they can be stored privately with you on your system. So,
but
say something
if
like
I store
Coinbase
it in, but if I store it in one exchange, is it not like TransUnion and all the same story? I have to store it in many exchanges because people don't use the same exchange.
Not necessarily. It's, you see, the database is different as well. So, you know what? When we do it with TransUnion puts it in a central database, and you have, and they in fact have your data completely open. When you go to Coinbase, what they have, they also store your wallet there, but it is something like that, but it's much more secure and much more, let's say, it's impenetrable compared to what, let's say, the traditional database model is, which is still centralized versus which is centralized storage versus storage where the data is stored across the network. So you're right in the sense that if you use a wallet provider or somebody who is storing your information, there is some vulnerability associated with that, or rather some control associated with that, but it's not the same thing as, let's say, Experian or TransUnion. But that is a pertinent question. Okay, the most secure way is to have it on your own, but most people are not able to handle that. So let's go to the the concept of what we are doing with IIT Kanpur. This is a proposal that we have in front of IIT right now. We talked about it for the last few months, and we are talking about implementing it right now. And I use this use case because it's something which is easily identifiable as opposed to some of the more financial services use cases. So we are talking about something called the Kanpur Super Quad, which is a virtual gated community for verified members and subgroups. What IIT Kanpur is doing is they are using email, and they're using WhatsApp, and they're using Slack, and some variation forms of groups to stay in touch with the 40,000 or so alumni. We are in discussion with them where we say we can store this as a verifiable credential, or we can, as long as IIT is able to validate someone's the legitimacy of someone's alumni status. So there may be such status, like, for example, they've kept a registry. They're going to, if somebody comes in and asks for a verifiable credential from IIT, they will go check the register, make sure that they are indeed who they say they are. There is a process of what you may call KYC or a what you call a digital ID verification. That means you take a picture, there's facial recognition process, all of that. After going through all of that, you get what is called a verified credential, which may have to be maintained. In some cases, it may not have to be maintained because once you're an alumni, you're always an alumni, but we may add more functionality to it. Now, what's the purpose of this? This is being deployed in the Super Quad is being deployed in a public open source community, which is pretty sophisticated in the sense. It's a community called Discord, or software called Discord, where which has video, audio, text. The good news is that it's pretty sophisticated. It's got a lot of functionality in it. You can create a lot of groups around it. The downside is it is the Wild West. There's a lot of garbage out there. I mean, just like Facebook, there's a lot of garbage. There's a lot of unsavory characters in there. So it is very valuable to create what you may call a safe haven using the underlying technology of that social media group, and putting guardrails on it, putting what you may call gates within that community so that only people with certain credentials can enter. So what IIT wants to do is create a one gated community, if you will, for all alumni. Within that, there will be one for, let's say, the 82 batch. There will be one for people who are interested in cultural affairs. There'll be one which will be people who are interested in just electrical engineering or chemistry or something like that. They want to create those Obviously, they're driven by the fact that they want to engage with all of us and be in touch with about 40,000 alumni. Right now, they're in touch with, I think, 15 or 20,000, and it's kind of low touch, and they're not getting enough money from us. I may put it bluntly. That they do want to get to raise their footprint and being able to generate money for the institute. So they have motivation behind it. The important thing here is that the what you call the maintenance cost of something like this is kind of a variation of WhatsApp or Facebook. The difference is that it's secure, and the second thing is that it's easier to maintain. So there isn't an administrator there. There'll be someone from IT who will be working on it. So that's one of the use cases which are a part of what we call Manatoko Kanpur. Manatoko is a Maori word for trust and verify. You can look it up. It's probably there on the internet, probably not, but it basically means trust but verify. The second thing is what is called as the Kanpur Angel DAO. DAO is actually, I didn't explain the concept of DAO. We could probably get into it a little bit, but basically a DAO is a distributed autonomous organization. And let me explain what that means. Wish I had drawn a picture of it, but basically an organization typically has, if you look at a corporate organization, there's a CEO, there is a CFO, there is a controller, there is a whole bunch of people in the management, and all of them work according to a set of guidelines. Now, when you talk about a DAO or a decentralized autonomous organization, there are no human beings. All of them are functioning based on a certain set of rules and a certain set of smart contracts. So what we are proposing is what is called an angel DAO. That means angel investors who are accredited and whose credentials have been verified can work with early stage companies that are being incubated at IIT Kanpur. Some of us may know that IIT Kanpur has a program by which at the end of third year you can drop out. You can take a 1 year gap, start your company and go. If it works, fine. Even if it doesn't work, you can come back and finish your fourth year of undergrad degree after that. So they're trying to build up a whole, let's say, slew of early stage companies that are incubated inside of IIT. The key thing here is that they are a venture capitalist who are going in there writing checks of about $500,000 or $500,000 to $1 million to incubate these companies. We have proposed to them that it can be done much better, because if you have a DAO, an accredited investor, you can have probably 20 people who are writing let's say a $5,000 check or a $50,000 check, instead of one person writing a $500,000 check, because it goes through much more review. And the criteria for making that investment is based on a set of rules that are predetermined. So you don't have a CEO or a CFO or somebody who makes the decisions. That investment is directed based on a set of rules that have already been pre-decided upon as a part of the DAO. I'm getting into a little bit more of detail than we should on this thing, but the important point to mention is that something like the DAO is enabled by blockchain technology and smart contracts that are associated with it to make it reliable and verifiable and uncorruptible, so to speak. The third concept is probably a much simpler concept, that just like we say we have somebody is verified, we have got what is called the Kanpur dossier, which may include KYC profiles or degrees. You may in addition to your BTech degree, you can put in your master's degree or your PhD degree in it, and it becomes a part of the verifiable credential, which goes on into the for verifiable for somebody else. These are kind of three simple concepts, and I think I had some. Yeah, actually, I did have some slide on that. Sorry, I didn't realize we had some slides on this, basically on what a gated community looks like, what a
Sonali or Sonali neck,
or what a what the DAO looks like, and also what the dossier would look like. So again, let me pause right here, because I'm sure this is, since all of us are familiar with the Institute, one has, you might have some questions here which ties in the concept of verifiable credentials, self-sovereign identity, with what we would call a practical application of the technology. So I'm going to take a pause here. Gopal, are there any questions that are coming in on this?
I have a question actually.
Yes.
Gopal, can I ask?
Yeah, go ahead. Go.
Yeah, go ahead, Sanjay.
Okay, so as I'm probably not paying full attention to what you're saying, but in my mind, I'm imagining, besides my degrees, etc., all of us have our own personal data, which is whether we want to store it in a wallet or including health information is one of the things I was thinking of, besides degrees,
Yes.
etc. So and the fields of this personal bubble or data or database, as I would call it, can be quite variable depending on what people's data looks like. But are there efforts to essentially, I don't want to say standardize, but query personal, flexible databases that can anonymously, or as you were explaining, just share whatever information I agree to share with a relevant party securely and with trust. How do we manage this? Because there's all kinds of things talking to each other, or we're making systems which seems a little bit disjoint. But maybe that's my own myopic view into what I'm hearing you say. But maybe there's a bigger picture that I'm missing. So I'll stop here. But how should we be thinking about this? Because Discord, I used to use Discord when I did gaming, etc. But is this really and I guess I should say, is this really the final solution, or what should we really be doing for a system like this to work for all of us, whoever you are, securely with trust and only sharing information that I want to share with any trusted party?
Yeah, in fact, that's actually a very good question, Sanjay, and I think it warrants a bit of a pause to sort of put this in perspective here. It is by no means the final solution. Getting access to a gated community with your, let's say, your IIT degree is what we would call a low-stakes solution. Yeah, if somebody finds out you're from IIT or not from IIT, it's not a big deal in terms of the knowledge. But as we go into more, let's say higher order applications, like for example, your accredited investor rating, this becomes a little bit more private information, and you keep going into this, you get into more and more detail on this. Now, I think what you're asking right now is, where is the technology in this to be able to do this for healthcare data, or to do with more, let's say, more practical or more day-to-day operations? The industry is not there yet, and it's not there for a lot of different reasons. I guess what we are aiming towards is something like this, where, and the financial services is a good example of this, where you do everything without an intermediary. Everything is deployable without an intermediary. We are right now in the very early stages of this kind of a network, or a reliable network, to do this, for a lot of different reasons, which we'll get into a little bit. But most important of that is that we've got to take a gradation of what you may call low stakes, medium stakes, and high stakes. What I would call something like this, and we actually had this conversation with the IIT guys, is that this is a low stakes involvement data. The data that you are a alum is low stakes data. If it's compromised, it's not that a big a deal. These are what we may call medium stakes. As soon as you get into the area of being able to put money behind it, that is where you're able to do exchange of currency, you're able to tokenize assets. All of these become higher and higher stakes. So whatever we're seeing right now is kind of a preview and, let's say, a proof of concept of what you can do as you get into more higher stakes solutions, like the ones which are showing here. So what I want to answer your question, Sanjay, is in a few different ways. Whatever we're talking about right now is low stakes. The technology does exist to do that, but the legal enforcement mechanism doesn't necessarily exist to do that. So, for example, if I go to a bank and say I want to tokenize my loan and sell it on the internet, the bank will say, fine, but just do give me a piece of paper to back that up, because I'm not going to accept a token and exchange with it, because the regulators won't allow it, and that kind of stuff. So we are. It is kind of fair to say that we are in the early stages, but the technology is advanced to a point where you can do low stake stuff on it, and it is the technology. Let me put it this way: the technology does exist to do high stakes stuff behind it, but the legal mechanism and the enforcement mechanism for bad behavior does not exist right now. It's kind of a long answer, but Sanjay, did I focus on the main issue?
Yeah, thank you. I understand the low stake approach to starting this thing, but in my mind, I was thinking, in my own bubble, there's got to be an inner sanctum of the stuff that is the most valuable to me. Then there's a outermost sanctum, which is the low stakes one, which okay, somebody breaches, it's not a big deal, like the IIT alum status, etc. But are people working on developing, I don't know, the right model, or maybe this sphere onion model is not the right one for how you want to approach this in terms of the stakes that are involved. But there must be some fundamental work going on how do you construct, if we agree that that's the final state that one wants to get to, then hopefully somebody is looking at that, right? I mean, I don't know, or are people basically interested in just getting the low stake stuff to work, and then we'll look at it, we'll punt the other part down the road?
No, it's actually not as bad as that. People are working on it, but there's one fundamental thing you have to understand, is that the concept of a centralized database controlled by a master is being turned on its head when you have a decentralized database where you own all your private data and nobody else does, and you have a means of securely communicating that with other people over the network. So the idea of so if one of the ways of looking at blockchain is a blockchain is a set of distributed databases, and anything to do with private data or your own data is owned by you and you alone, and you decide what to share at what point of time. So there are no layers of the onion as far as your data is concerned. As far as you're concerned, you own everything. There are sort of there is a basis on which you can set rules as what you can share with whom, and as opposed to this is in direct contrast to what we have right now, where let's say Experian or TransUnion or even a bank, they own a shitload of data about you, which can be compromised and which you may not even know about. But the basic structure that is used right now is centralized database. That database gets compromised in any way, it basically compromises your ability to it compromises your ability as a citizen, in the sense that you own this because you own the data. In fact, you want to hold that thought for just a minute, Sanjay. When you address it, I'll address it in the next.
Yeah. Sorry, I didn't mean to. I just had.
Yeah, I think Subodh has a question, which is Subodh. Do you want to ask it, or you got your answer?
Shirish, about the IITK alumni database or whatever it's called, why can't a normal database system handle this? I mean, why do you require a distributed ledger, and where does this distributed ledger then sit? Does it sit with the alumni also?
No, so the different concept here. What we are, when we are deploying it on a private blockchain, the database still is maintained by IIT Kanpur. That's where the data lies, and that is, they are the verifier of the data. They maintain, like, that's one central place it's located. What they're issuing you is a verifiable credential, and the only information that verifiable credential contains is that you are a part of that of their database of people who have graduated from the institute. And that verifiable credential is what you present whenever you go to any of these communities or any other. You go to a bank to get a loan or to get a credit card, all you have to if verifying that you're an IIT Kanpur alumni is important, you get to produce that. And the other option there is that every time, now we have 40,000 alumni going to what 10,000 or whatever number of 3,000 or 4,000, or I don't know what it is, large number of people come in every decade. If somebody applies for a loan and that loan basically, or let's say a bank, and they say that you have to verify that you're an IIT alumni, it goes through a process. There is a process by which they go through right now. It's much where they check with the institute whether it's true or not. Instead of that, you could carry that validation in your pocket, saying that I have this verifiable credential issued by IIT, and that becomes my passport or my qualification to get into the community. So and that is stored in your wallet, and that wallet is and that credential is what you produce. And what that guarantees, or what that guarantees, is that your identity has been validated. That means IIT has checked your face, your background, probably your passport or something, made sure that you're the person who they say they are. They're using roll numbers, by the way, so right now, so they match that roll number with the facial recognition and a bunch of other things. So at the end of the day, you've got the equivalent of a driver's license, which you can take and produce anywhere. Does that answer your question, or not?
Okay. Okay. It'll take time to digest.
Okay, we can get into more of it.
Yeah, fair enough. Fair enough. Continue, please. Yeah.
Shirish, can I ask a question here? Following from what Subodh asked, this is Saurabh.
Yeah.
See, currently we have the Aadhaar card where it is maintained centrally by the government, and I go somewhere and then they take my thumbprint on a certain device and they check my identity, right? How? I mean, that is not done on blockchain. So why can't a simple system like that suffice for this?
For a few different reasons. In fact, the way we have defined SuperQuad for IIT is that it would use Aadhaar card as a validation mechanism to go in there. So you can use your passport or your driver's license or your Aadhaar card. So what the Aadhaar card does, Aadhaar card is a biometric system. So it validates your identity based on biometrics. And then and it has a completely different approach where and they do use a centralized database, which is I guess a form of vulnerability in itself. But that can be used, but you don't have to carry your Aadhaar card around. You don't want to carry your Aadhaar card around with all the other validations that go with it to be able to do. The verifiable credential incorporates that into one simple into the wallet, which can be deployed pretty much anywhere you want to. So I would say Aadhaar card, at least in the way we're deploying it, is a part of the system, but it is used as a basis for qualification. And remember, in your Aadhaar card, there's a lot more information that is on there, which is again gratuitous. You don't really need that when you're trying to enter, let's say, a Discord community. All you need to know is who you say you are and that you are a student and nothing else. So the Aadhaar card is an essential part of, let's say, the establishing the identity, but it could just as well be a passport or a driver's license. And again, the Aadhaar card is only in India, which is a very good system right now. It is not global.
Snet, let's move on, and it's 1 hour into the talk. So let's try and wrap up the talk first before we answer any more questions.
Okay, so let's talk about the blockchain and regulations. We talked a little bit about the history. We talked about the technology. We want to talk a little bit about the regulation. And this is kind of goes back to Sanjay's question about privacy. There was something called what is called the Cypherpunks Manifesto, written in '93 by a guy called Eric Hughes and a bunch of cypherpunks. And they basically said their assertion was that my data belongs to me and not to anybody else. And the technologies can actually enable that kind of thing to happen. So it gives the example of back in the day when, let's say, the Freemasons or whoever, the Skull and Bone Society, they had their secret handshakes and whispers. That can be actually translated in, that can actually be implemented through technology. But the fundamental notion here about the Cypherpunk manifesto is that the data, my data belongs to me and not to and TransUnion may not even borrow it or touch it, or Experian may not borrow it or touch it. Modern technology can help you do that. So this is a bit of a what do we call a political statement made by a bunch of technologists. And the reason it's important is because that became the foundation for a lot of what do we call privacy based technologies, which are now actually being used in commercial applications like the ones which I was highlighting over here before. The fundamental notion is that data belongs to you and not to anybody else, and you get to share whatever you want to. That had its origins in this what is now known as the Cypherpunks manifesto. It's actually a document as well, probably a 2-3 page document which covers this. Now, I'll get you kind of to the end of our talk here, but I want to talk about regulation. Now, as you can imagine, and this kind of addresses Sanjay's points, and to some extent what I think someone like Sap would be interested in as well. There's a guy called Lawrence Lessig. He's a legal scholar, I think at Harvard, if I'm not mistaken, or Stanford. He was at Stanford, but I think he's at Harvard right now. Where when you have such a major change in technology, his argument is that you don't legislate it by regulation alone. You don't put cops at the stage to be able to implement it. You have to consider what the social norms are that is acceptable. You have to consider what the market forces are to be able to point it. If someone has to break into your system, it should cost him a lot of money to be able to break into the system. Then there is the underlying, let's say, the architecture, and then there is the law. So Lawrence Lessig's model for, let's say, the basis of regulation is kind of important, because if you go by the Cypherpunk manifesto, they are kind of, let's say, radical in their approach, saying, I own everything and I don't need nations, I don't need banks, I don't need anything else. I'm an island unto myself, and it becomes kind of an extreme position. Whereas Lawrence Lessig, who was, I guess for lack of a better term, is a legal scholar, basically said you have to implement laws in the context of social norms, in the context of the market, and in the context of architecture. There's a whole this is a 2-hour discussion by itself, but it's important to know that there's a lot of investment that has gone into it. Now, and I'll conclude my talk here with kind of just the one aspect of the technology, in the sense that people will say that the technology does exist right now to do everything that you want to. We can eliminate the banks, we can eliminate governments, we can eliminate nations and live on our own. Like Wyoming has a lot of these DAOs, for example, where they're living off, which are completely autonomous organizations, or what we call organizations which function like based on smart contracts. But the closing statement I'd like to make is related to the what is called regulatory guidance, where just because something is possible doesn't mean it can be done in the context of what Lawrence Lessig is talking about, and which is basically where something may be technically feasible, it is not necessarily practical from the point of view of the legal infrastructure, the social norms, and the market infrastructure that exists right now. So I'm going to conclude this talk by summarizing what we discussed. We discussed a historical perspective on blockchain. We discussed key technologies and the principles of blockchain. We talked about applications and use cases. I took a simplified use case of IoT. There are many more in the financial services and the healthcare space based on the same principles. And then we talked a little about regulatory implications, because it is impractical to talk about technology in isolation the way that, say, the cypherpunks are doing. It has to be in the context, the broader context. And I think the Lawrence Lessig model for that is probably the most holistic approach to doing this in a practical form. So that concludes my talk. We can go to questions.
Thanks, Shirish. Excellent talk. Sanjeev Rangras, do you want to read out your comment, or that was just?
I can't hear you, Sanjeev. Sanjeev, you're on mute.
Oh, I'm so sorry. I said in India we have a DigiLocker where all our documents are stored, whether it's a driver license, whether it is an Aadhaar card, whether it is my college degree, it is now beginning to store, and it's a valid thing. So I need not carry the physical document, and I'm able to access my DigiLocker and show it, and I'm able to give access to specific organizations to access specific parts of my DigiLocker.
So that is the concept behind what we're talking about. The whole idea of a digital ID. Now, even in the US right now, we have a real ID. So I have a passport, which is a US passport, which is also a real ID, which I can carry with me. I think my driver's license I can put into a digital form, so I don't have to carry my driver's license with me in California in the future. So yeah, the basic concept is the same.
Shirish, but none of these are blockchain enabled, right? I mean, is DigiLocker based on blockchain, or is
no? I know.
Not necessarily, no. But what the blockchain does is it basically it lets you present that at various forms. If you put this on a verifiable credential using the blockchain technology, they become the basis for sharing that with anybody that you want to share on it. So, for example, if you were to get into a Discord community, that can be put on what we are using as a Chia blockchain. That because it facilitates the sharing of that information in an encrypted form, which makes it much easier to be presented in different places. He may not right now. What Sanjeev is doing is sharing it selectively with people who want it, and there may not be a standard to doing that. So if, let's say, 20 people want the same information, they will probably have to ask him 20 times. If we put it in a verifiable on the blockchain, it makes it easier to manage the sharing of that information.
There are some. Bharat, just wait for a minute. There are some questions online.
I'll just clarify one.
Shailesh asks a simple question, which is, I know it's simple, but it's an interesting question. What's the difference between Bitcoin and Dogecoin?
There are different forms of cryptocurrencies that were implemented. Bitcoin came in first, Dogecoin came in later, and anybody can start a coin. There are literally hundreds of coins that are available, started by different people. One of the concerns about what is called coins which came out in 2018, 2019, there's a whole flood of them. A lot of people use coins for all kinds of garbage, and basically took money from a lot of people and pretty ran away with it. So it's not a Bitcoin, for that, for example, is secure as well. Or rather, it's probably more secure because there's so many people who have it. But Dogecoin was just started as a joke, and people basically put money into it, and some people bought, some people sold it, and it was I guess highly unregulated. The Dogecoin is kind of an example of one of the reasons why we need the regulatory system to work within the framework of the law, and within the framework of what is the socially accepted norm of the market and the law. One of the reasons why Dogecoin and people like that are one of the reasons why the US is very actively pursuing regulation in this area. And this is actually I didn't show the slide earlier, but basically these are the forms of regulation which have come up, which will eliminate marginal things like Dogecoin coming in. But the fundamental difference is technically not difference from a let's say exposure and regulatory point of view. There is like at risk, it's quite different.
Okay, I'm going to ask one more question from BS, which was on the thing. And after this, please don't post your questions. Just start asking them. So last question from the chat is BS. BS, you want to ask your question? After that, please just ask questions directly. No more chat.
Yeah, just you said that sometime in future they may release more Bitcoins. So I'm just curious, who gets the power to do this, and who died and made him king, kind of thing. And by releasing more Bitcoins, doesn't it dilute the existing value of the Bitcoins? And isn't that a bad thing?
So that actually is pre-programmed into the systems. So Satoshi Nakamoto, whoever he is, or a group of persons he represents, they programmed it right into the way Bitcoins were set up in the first place. They decided on a fixed number of Bitcoins. They decided when they were going to be, when the mining would expire. All of that was decided upfront. And yes, who died and made him king? I don't know. I mean, people just followed him at that point of time, and now there are enough people following him that whatever his rules he or she or they had laid down at that point are being followed. So see the whole. I think, but I would say the spirit of your question is very important, Talia, because the whole idea of if you go back to the Satoshi Nakamoto, since we're talking about Bitcoin, let's go back to the Satoshi Nakamoto manifesto. If I can get it back to that. I don't know if this thing work or not. Yeah, here it is. His idea was a peer-to-peer currency. That means no single financial institution or nobody, including Satoshi Nakamoto, would control it. It was already preset, and the rules are already set, and everything has to function without supervision. So the simple answer to your question, and then it's kind of the more of the background to the question, saying decentralization is a key part of what this is about.
So Shirish, I'm still maybe a little fuzzy on, you talked about the 3 different mechanisms of consensus building on the distributed ledger, the proof of work, the proof of and proof of space. Yeah. So why would I be interested in making this easier? Because if I'm worried about privacy and trust, I want to make it extremely hard for somebody to try and break into this rather than make it simple. But I'm missing something. Clearly, it doesn't feel right to me that if I want a fake consensus, it shouldn't be easy for me to do. It should be very hard. So help me think about this, because if proof of space is fast, but it's different risk and medium risk, while proof of work is really the best security, why should I allow my systems and my data to use less security than, what do I gain out of it?
You're right in the sense it doesn't make it easier. It does make it less of a, let's say, a carbon footprint, or it becomes the limitations of computational power are not necessarily there. Probably we could probably take this offline, but I think the important part is that the proof of work, when computational power was considered as the way of doing this in Nakamoto's time, so computing power was not such a big deal. I mean, you could just put in a bunch of CPUs or probably GPUs and get things done. This went so far out of whack that whole companies and they were founded on creating GPUs and made a lot of money just doing just that, and it became a pretty much a dent on the environment and things like that. The proof of space part, and again, I'm not an advocate for one or the other. It doesn't make it simpler, or it doesn't make it easier. It just makes it cheaper in terms of a carbon footprint, and cheaper in terms of the cost required to mine it. There are still the same levels of, let's say, puzzles and stuff that you have to go through, and it's called farming right now as opposed to mining. So let's say the simple analogy is that this is on the first one is gold mining, and farming is, it takes time to grow it, like it's like in a garden, you plant the seeds and it takes time for it to go to a certain point of time. So it's cheaper. It is a bit slower as well. So just because there isn't an easy answer to say to trade off one versus the other, and that would be a longer conversation which we can get to. Right now, proof of space is still very unusual. It's very uncommon. People are still doing a lot of proof of work and proof of stake. The whole world has not migrated to proof of space yet, because there aren't enough